Welcome back to Wes Explains Best. We're doing part 3 of section 3.3, applications of systems of equations. A lot of students don't like systems of equations, and these are word problems related to systems of equations, so it's especially difficult. I'm going to try to break this last example down into the easiest form possible. Let's get started. A car travels 250 kilometers in the same time that a truck travels 225 kilometers. If the rate of the car is 8 kilometers per hour faster than the rate of the truck, find both rates. The first thing we have to understand is, what is a rate? Well, a rate is a distance divided by time. Like, think about most famous example, speed. Drive down the road, you see a speed limit. What does it say? It gives you miles per hour. Miles is a unit of distance. Hours is a unit of time, and so that's your speed. Speed is a way that we can measure a rate, okay, how quickly something changes. Now, this problem, it's helpful if we have this little table here, okay? So if you want, create it, or if you already have this set of notes, go ahead and use the table. But let's input what we know. We say a car travels 250 kilometers, so we know this distance. A car travels 250 kilometers in the same time that a truck travels 225 kilometers. Okay, so I'm not sure what happened with that 0, but let me redraw it. There we go. And that's 225 kilometers, okay, for the truck. Now, here's another key piece of information. We say same time that the truck travels 225 kilometers. What does that mean? Same time means we're having the same amount of time pass. So if we have a variable here, we could say this is t, but we're only going to keep it temporarily because it's the same. Both these times are the same. If this car traveled for 1 hour, which would be crazy because it would be going 250 kilometers an hour, but whatever. If it traveled in 1 hour, the truck traveled 1 hour. If the car traveled 2 hours, then the truck traveled 2 hours, okay? So these have to be the same. So I'm just going to leave it as t for now. So the next thing we need to know is if the rate of the car is 8 kilometers per hour faster than the rate of the truck. Now, so how do we say the rate is 8 kilometers faster? Well, let me change colors here. If the rate of the truck is r, then the car would be r plus 8, okay? Because that's what we have here. And so we're asked to find both rates. Now, this is kind of like our first most important step, is we have to define what is it we're looking for. We're looking for both rates. So we need to find the rate of the car, and we have to find the rate of truck. And we're going to define our variables. We're going to label them. I'm going to say C is the rate of the car, and T is the rate of the truck. Oh, I already used T, so what should I use for, why don't I call it big T? I'm going to use big T. Why not? I'm going to use big T for the truck. So C for the car, big T for the truck. Okay, so I'm trying to find both these rates. Now, in order to find these rates and how they compare to each other, I have to use this. The rate equals the distance times divided by time. So let me rewrite it here. I'm going to use red again. R equals D over T. Now, I'm going to set this up for two different problems. I'm going to say the car over here on the left. I'm doing this one a little bit differently than I did the other examples, if you may have noticed, and the truck on the right. So my car's rate, as we already know, well, if we said R is the rate of the truck, then R plus 8 is going to be the rate of the car. So we say R plus 8 equals 250 over T. Okay, so R plus 8 equals 250 over T. Now the truck is going to be a little different. We have 225 over T, okay, over T equals R. So we have our rate of the car, rate of the truck, but the problem is we have two variables, okay? We don't like that, and we especially don't like the denominator being t. So what can we do? Well, one thing you can do is you can get rid of the variable in the denominator. You should definitely do this by multiplying both sides by t into both these equations. So we're going to multiply both sides by t, and that will get rid of the denominator. How does that change it? We're going to get t times R plus 8, you got to keep it in parentheses like that, equals 250. And then we have, let's do this one, T times R equals 225. Okay, so we have two equations. We have two variables. Okay, so what do we have to do? Well, this one's not going to be easy to use elimination on. So what I'm going to do is, because we have t in both, I'm going to solve for t in this equation and substitute it in there. Now, this is just one way I suggest doing it. Doesn't mean it's the only way. But I'm going to solve for t in this one. So I'm going to divide both sides by r. Divide by r, divide by r. And I get t equals 225 over r. Okay, now, what do I do with this? Well, I'm going to use substitution. Since I know this is the value of t, then I can substitute this in for t in the second equation. That's what substitution is all about. So I'm going to replace that, and I'm going to say 225. Where should I write it? I guess I'll write it over here. 225 times r plus 8. Oops, over r. Sorry, 225 over r. That's my value of t. Times r plus 8 equals 250. Okay, now what do I do from here? Well, now I only have one variable, so I need to distribute and then solve for r. So I'm going to get 225 over r times r. The r's are going to cancel. I'm going to be left with 225. Then I have 225 times 8. Okay, I'm going to get my calculator out real quick here. 225 times 8. And that gives me 1800. But then I have that over r, because I have to multiply again. The r doesn't stay permanently canceled. Equals 250. Okay, I'm going to subtract both sides by 225. 225. I get 25 equals 1800 over r. And I could do multiply both sides by r and then divide by 25. I think I'm going to do that. I'll multiply both sides by r to get the r out of the denominator. R over 1 if you want to do that. Cancels on the left side. We get 1800 equals 25 r. Now I divide both sides by 25, divided by 25, and we get our value of r equals 1800 divided by 25. And that equals 72. Okay, so what does this 72 represent? Well, initially we said r is equal to the rate of the truck. So if r equals the rate of the truck, then we know this equals 72. Then we just plug this back in, up here, 72 in for r, and we do 72 plus 8 to get our rate of the car, so that is 80. So our car's speed is 80, but we need units. Equals 80 kilometers an hour, and the truck is 72 kilometers per hour. And that's how you do this problem. So this time we use substitution instead of elimination. Sometimes that's just easier, but we got our answer that way because you can use either method, and there's our two answers. So a little bit more complicated of a problem. Hope you enjoyed this video. Thanks for watching. I look forward to seeing you next time on West Explains Best. Take care.